Meow. Hey, all you cool cats and kittens. Welcome to the final lesson for Unit 3, Solving Problems with Trigonometry. All right, we've learned an awful lot about trigonometry. Let's actually solve some real-ish type problems. All right, so the first type of problem that we're going to look at is what we call solving a right triangle. When I ask you to solve a triangle, that means that you're finding all three angles and all three sides. That's what it means to solve a triangle. Find everything. So here's a classic example where we are going to solve a triangle. So the first thing is, obviously this is a 90-degree angle, so that's pretty simple. That's pretty obvious. How do we find the other angle? Well, come on. The three angles of a triangle always add up to 180. So if you take 180, subtract the 90, subtract the 34.2, the remaining angle right here is 55.8. So angle big B is 55.8 degrees. Double check your work on that as always, just to be sure. Can't hurt to do it twice just to make sure you didn't type in something silly and get that answer wrong. All right, now we got to find the missing sides. And we could use Pythagorean theorem, but the problem is we only know one of the three sides. So Pythagorean theorem is out for right now. But we're going to have to use trigonometry, right? And this should be easy. So you actually have a choice. You could find A first or C first, doesn't really matter. Let's go in alphabetical order and find A first. So if I'm going to find A, I actually got a couple options. Actually, I got several options now that I know this angle is 55.8. I could do cosine of 55.8. Excuse me, not cosine. I'm so sorry. Tangent of 55.8 degrees is opposite 19.4 divided by adjacent A. I could do tangent of 34.2 degrees is opposite A divided by adjacent 19.4. I got a lot of different options. I'm going to go ahead and use the 34.2. So I'm going to do tangent of 34.2 degrees equals the opposite side A divided by the adjacent side 19.4. And now I'm just going to solve for A. So to solve for A, all I got to do is multiply 19.4 to the other side. So 19.4 times tangent of 34.2 degrees equals A. When you do go to your calculator, please make sure you are in degree mode because we are definitely working with degrees in this problem. So 19.4 times tangent of 34.2 degrees is 13.184. 13.184. So A is 13.184. Easy. Really easy. All right, now that I know A, I could use Pythagorean theorem, but I mean, I don't like squaring these decimals. That's going to get kind of ugly. So why don't we use another trig function, right? Well, to find C, I could use cosine. Cosine of 34.2 degrees equals adjacent 19.4 divided by hypotenuse C. All right, that's easy. Or now that I found A is 13.184, I could do cosine of 55.8 degrees equals adjacent 13.184 divided by C. So I got a lot of options. I can even use sine of 34.2 degrees equals opposite 13.184 divided by hypotenuse C. You got options. Okay, so how do I solve this? I'm first going to multiply the C to the other side. So I have C times cosine of 34.2 degrees equals 19.4. And then I'm going to divide both sides by the, divide everything by the cosine of 34.2 degrees. So C equals 19.4 divided by cosine of 34.2 degrees. So again, make sure you're in degree mode. 19.4 divided by cosine of 34.2 degrees is 23.456. C is 23.456. All right, so that's solving a triangle. I literally found all three sides. I was given B. I found A and C. I was given angle A. I found angle B. So I found everything I need to know. That's solving a right triangle. Let's do a second problem here. Now, this time, the triangle that's drawn, ACB, is not a right triangle. But if I measure the height of this triangle based on the way this picture is drawn, then I actually do create a right triangle. So, a lot going on in this triangle, but they want me to find sides A, C, and B. So it's actually pretty simple. You just have to look at two triangles. So the first triangle I will highlight in green. That's this triangle right here. That's a 44-degree angle, and the opposite of 44 degrees is 28. And then in orange, I will highlight the big triangle that has an angle of 28 degrees. And again, opposite of that 28 degrees is 28 as a side length as well. All right, so here I go. So let's look at the small triangle first. I can find A using this small triangle right here. So in that small triangle, I'm going to go ahead and use sine. Sine of 44 degrees equals opposite 28 divided by the hypotenuse A, and that's going to help me find side A. That's pretty easy. So multiply the A over. I get A times sine of 44 degrees equals 28. And I'm going to divide everything by the sine of 44 degrees. So I get A equals 28 divided by sine of 44 degrees. Make sure when you type this into your calculator, you are in degree mode. 28 divided by sine of 44 is 40.308. 40.308. So that is the length of A. All right, now I'm going to look at this big triangle right here. And I'm going to look at the big triangle, and I'm going to do something very similar to help me find C. This time I'm going to use sine of 28 degrees equals opposite 28 divided by hypotenuse C. So I'm almost ignoring this line right here, and I'm looking at this big triangle. Sine of 28 equals the opposite 28 divided by the hypotenuse C. So once again, I'm going to multiply that C over to the other side. Divide everything by sine of 28. So I get 28 divided by sine of 28 degrees. And again, make sure you're in degree mode. 28 divided by sine of 28 degrees is 59.642. 59.642. All right, how do I find B? Well, actually, B is going to take a little bit of work because B is actually not involved in a direct right triangle, right? B is not any side of a right triangle. But here's what I can do. I can find this entire value down here. I'm going to find all this, that big, long value. And let's call that, I could call that W. Then I could find this angle right, or this, not this angle, this side right here. I could find this side right here. Let's call that M. And then what I could do is once I find W, by using the big triangle, I could then take W and subtract M once I find M, and W minus M would equal B. W minus, oh, it's not W. W minus M equals B. So all I got to do is some work to find M and W, and I'm good to go. So how do I find M? Well, I'm going to go ahead and use tangent. Tangent of 44 degrees in the small triangle is opposite 28 over adjacent M. Multiply the M over, divide by tangent of 48. So M equals 28 divided by tangent of 44. I think I said that wrong. I'm sorry. So again, multiply the M over, then divide by the tangent of 44. So 28 divided by tangent of 44. Make sure you're in degree mode. 28.995. M is 28.995. All right, now I got to do the same thing with the big triangle to find W. Tangent of 28 degrees equals the opposite 28 divided by the adjacent W. Multiply the W over to this side, divide by the tangent of 28. So W equals 28 divided by the tangent of 28. So 28 divided by tangent of 28, and I get 52.660. W equals 52.660. So again, now to find B, I'm going to take that big length W, which was 52.660. I'm going to subtract that small length M, 28.995. And once I do that math, 52.660 minus 28.995, I get B to be 23.665. 23.665. So sorry, my work's a little scattered here. Kind of looks like a lot of your guys' work, kind of all over the place. But that's okay, as long as you understand I did some work here to find A and C, which were the hypotheses of the two triangles. And then B could not be directly found. I had to indirectly find it by finding the adjacent sides and then subtracting them. All right, let's look at some more wordish type real-world problems here. And first, we're going to do a quick little lesson on angle of elevation and angle of depression. So an angle of elevation is the angle through which the eye moves up from a horizontal to look at something above. So if you are standing and you're looking up, the angle at which your eyes look up is the angle of elevation. And the angle of depression is the exact same thing, but if you're looking down. So it's the angle through which the eye moves down from the horizontal to look at something below. So what I'm saying here at the bottom should make a lot of sense. For two observers at different elevations looking at each other, the angle of elevation for one equals the angle of depression for the other. So let me draw some quick pictures of this just to understand. So if here is an airplane and I'm on the ground, I'm looking up at that airplane, the angle of elevation is the angle that I'm looking up. That would be this angle right here. Now, if I'm in the airplane, maybe I'm the pilot, I'm in the airplane, here's my horizontal, and I'm in the airplane, I'm looking down, there's my angle of depression. It's the angle looking down. And what they're saying is that you have two people looking at each other, one looking up, one looking down. These angles of elevation, angles of depression are actually equal, and that goes back to theorems that you should have learned in geometry about parallel lines. Those would be alternate interior lines, which are congruent, if you alternate interior angles. Anyway, I'm not going to give a big geometry lesson here. So again, angle of elevation is simply the angle looking up at something above. Angle of depression is looking down at something below. But again, it's all measured from the horizontal. So if you're on the ground, the horizontal is like the ground. If you're up in the air, you got to think of the horizontal as straight across, and then the angle of depression is looking down. All right, so let's do a good word problem that uses these ideas. So at a point 200 feet from the base of a building, so you can kind of see that in the picture there, the angle of elevation to the bottom of the smokestack is 35 degrees. Okay, so again, here's that point right here at the 200 feet from the base of a building, and the angle of elevation looking to the bottom of the smokestack is 35 degrees. That's this angle right here, 35 degrees. And the angle of elevation to the top of the haystack is 53 degrees. So again, my angle of elevation looking all the way to the top of the haystack is 53 degrees. That's this entire big angle here. All right, so they want me to find the height of the smokestack. Okay, this is actually pretty easy. I think you're going to understand this very easily. So notice that I did not ask you to find the height of the building A, but it is necessary to find the height of the building because that's this small triangle. So let's look at this small triangle, right? The 35-degree small triangle that is looking up to the top of the building or the bottom of the smokestack. So I'm going to go ahead and use tangent because tangent of 35 degrees equals opposite A divided by adjacent 200. Again, looking at this small triangle, maybe I'll try to highlight it here. Here is this small triangle right here. That's kind of cool. Highlighted there. And in that small triangle, we have a 35-degree angle, and tangent of 35 degrees is opposite A divided by adjacent 200. So that means 200 times tangent of 35 degrees equals A. Now, I'm not going to calculate what that is because I don't want to round in the middle of a problem. I actually want to leave it like this because that is exact. Now I'm going to look at the big triangle, the overall big triangle, and that big triangle, tangent of 53 degrees equals opposite A plus S, because the entire opposite side of the big triangle is A plus S, divided by the adjacent 200. So that 200 at least is shared between the two triangles. So let's see here. So I'm going to multiply that 200 over. So 200 times tangent of 53 degrees equals A plus S. The question wanted me to find S. I was trying to find the smokestack. So I'm going to subtract A. So 200 times tangent of 58 degrees minus A equals S. So now I'm just going to substitute in 200 times tangent of 35 for A. So 200 times tangent of 58 degrees minus 200 times tangent of 35 degrees equals S. And again, the reason why I didn't actually calculate what A was is because I didn't want to round the middle of a problem. I'd rather keep it exact, 200 times tangent of 35. So to find the height of that smokestack, I'm just going to go straight to my calculator, and I'm going to start typing. Make sure you're in degree mode. 200 times tangent of 53 degrees. Did I say 58 degrees? Yeah, I think I just slowly had a brain fart. So again, it was 53 degrees, but I slowly morphed that 53 into a 58. I'm so sorry. So that's 53 degrees. So 200 times tangent 53 degrees. On your calculator, make sure you close that parenthesis after the 53 degrees. Then subtract 200 times tangent of 35 degrees. And I get 125.376. S is 125.376. And that's going to be measured in feet because that 200 was measured in feet. So there is the answer to the height of the smokestack. Pretty easy. And it just took a little trigonometry to figure out. All right, let's look at another problem here. I love this problem. It's a good one. So from the top of a 100-foot tall building, a man observes a car moving towards the building. The angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation. How far does the car travel? So in the picture here, here's the guy standing on top of the building, or maybe he's laying down. There he is, whatever. He's on top of the building, and he's looking down at this car. And here's the car right here, and he's looking down at an angle of 22 degrees of depression. But remember, as I mentioned earlier, from the car's perspective, the angle of elevation would also be 22 degrees. So again, if the angle of depression is 22 degrees looking down, the angle from the car looking up is also 22 degrees. And then the car moves. The car drives a distance of x, and that's the distance I'm trying to find. I'm trying to find the distance the car traveled, which is x, and now the car's right here, and his angle of elevation is now 46 degrees. So I could draw that right here as well. That's his angle of depression, His angle of depression is 46 degrees, which means that from the car's perspective, if you're in that car looking up at that person on top of the building, your angle of elevation is also 46 degrees. All right, so the important thing is that you realize that I have two triangles, okay? I got this small triangle right here. And if we look at that small triangle for a second, we have to incorporate this distance d. Now, I know I didn't ask you for d, but it is required, and you'll see why in a second. So looking at that small triangle, I know that tangent of 46 degrees equals opposite 100 divided by adjacent d. Multiply the d to the other side, I get tangent of 46 degrees equals 100. Divide by the tangent of 46, d equals 100 divided by tangent of 46 degrees. All right, that's going to come in handy in a couple moments. Sorry, my handwriting's kind of sloppy. It's this writing tool I'm using. All right, so now I'm going to look at this big triangle. And this big triangle here is highlighted in orange here. Okay, there it is. In that big triangle, I have tangent of 22 degrees is the opposite 100 divided by the adjacent x plus d. So that's why I needed d, okay? Because x is not involved in a right triangle. So I can't directly find x because x, the distance the car travels, is not directly involved in any right triangle. So I'm using d to help me see the right triangle because x plus d is the base of the big right triangle. So that's how I can kind of put all this together. And 100 is the shared side. 100 is the only side that's shared between these two triangles. So let's see here. So I'm going to solve this for x. So I'm going to multiply the x plus d to the other side. X plus d times tangent of 22 degrees equals 100. I'm going to divide I'm going to divide the tangent of 22 degrees over. So x plus d equals 100 divided by tangent of 22 degrees. And then now I want to find x. So x equals 100 divided by tangent of 22 degrees minus d. But I'm going to replace that d with what I found d to be earlier. So I'm going to replace that d right there with 100 over tangent of 46 degrees. So it's similar to that last problem we did, where I want to find x, and I have to find a trig equation that can help me find x, but I have to incorporate d, even though I really don't care what d is, I got to incorporate it. So now I'm just going to go to my calculator. Be very careful typing this in because we got fractions, so use parentheses. So 100 divided by tangent of 22 degrees. Close the 22 degrees, close the parentheses for the fraction, minus new set of parentheses for the 100 divided by tangent of 46 degrees. Close the 46, close the overall parenthesis for that fraction, and I get 150.93, actually round to, if you round it correctly, it'd be 0.940. And that would be measured in feet as well. Why is it measured in feet? Because the 100 was measured in feet that I was using in this problem. So the distance that the car traveled over the course of this time period was 150.94 feet. Pretty cool problem. Hopefully you agree it's pretty easy and you don't mind it too much. All right, the last type of problem we're going to deal in a real world scenario is ships at sea. And in surveying and navigation, directions are generally given in terms of bearings. A bearing measures the acute angle that a path or line of sight makes with a fixed north-south line, as shown in these figures below. For instance, the bearing of south 35 degrees east in figure 4.82 means 35 degrees east of south. So I know it's a little bit confusing. So here's how we measure bearings. Bearings, first off, are always measured from the north or from the south. We never measure an angle from the east or west. So when we say south 35 degrees east, what we mean is that's basically going southeast. Everybody should know what southeast is. Southeast is southeast, right? So here's that southeast direction. And it's 35 degrees measured from the south. So it's not measured from the east. It's always measured from the south, always. Northwest, 80 degrees. Obviously, northwest is this direction. Northwest, I mean, hopefully you guys get that. But again, the 80 degrees is the bearing measured from north. We never measure from west or east. Here's another one. This is northeast, 45 degrees. So again, northeast. Everybody knows where northeast is. There's northeast. And the 45 degrees is measured from the north. So you always measure the angle from the south or from the north, but the northwest, northeast, southeast, southwest tells you roughly what direction that goes. So I recommend drawing a little compass, and once you draw a little northeast, southwest compass, then all you got to do is follow the angle. I just got to be extremely careful to tell you, always measure the angle from the north or from the south, never the east or west. All right, so here is this problem. This is a really good problem. I love this problem. I love it so much, a lot of kids hate it. All right, a ship leaves port at noon and heads due west at 20 knots, or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 55 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. So here is port. And it says a ship leaves port heading due west. So it heads straight west at 20 nautical miles per hour. Then at 2 p.m., it changes course. So from noon to 2 p.m. is 2 hours. Over the course of 2 hours, it was traveling 20 nautical miles per hour. So over 2 hours, it traveled 40 nautical miles. Duh, if you go straight west for 2 hours at a rate of 20 miles per hour, you just covered 40 nautical miles. At this point, it decides to change direction. And I'm actually going to draw a little compass here so we can understand its new direction. At this point, it's now going to go northwest. And I just realized that I kind of drew my picture poorly. I'm going to run out of room. So let me start over kind of. So here's port. And we're going to start going due west for 2 hours, 20 miles an hour, 40 nautical miles. And once I stop, I'm going to change direction to northwest. So northwest is this direction. And I'm going to go 55 degrees north of west. So that is right here. There's my 54 degrees. And again, it's measured from the north. So I'm now going to go northwest and at an angle of 54 degrees measured from the north. And I'm going to stop at that point. And now it's 3 p.m. So that means I traveled for 1 hour. Because remember, 2 hours got me 40 nautical miles due west. And then I changed my course to northwest 54 degrees. And I'm going to do that for 1 hour, because from 2 o'clock to 3 o'clock is 1 hour. So that means that would be 20 nautical miles because I was going 20 miles an hour. So in 1 hour, I can go 20 miles an hour. And now the question wants me to find, how far am I from port? So they want me to find my distance all the way back to port. And that is a very poorly drawn straight line. Let me draw that again because it should be a straight line. The shortest distance between 2 points is, of course, a straight line. And that's not much better, but sorry, it's best I could do. All right, so the first thing I got to realize is that, well, I don't have a right triangle. So I need to kind of like force a right triangle to be drawn. So one thing I could do is I could draw this right here. That creates a right triangle. but only creates one right triangle. Oh, but I guess I could also do this. Check this out. I could drop this straight down here, and then I have a big right triangle here, right? That kind of makes sense. And that actually might be the best thing to do, because if I drop this down, I look at this big right triangle, and this big right triangle, the hypotenuse, is the distance from my endpoint to port. So that's the distance I want to find. So that's kind of cool, because that's the big distance right there. So how can I now find everything else that I need? Well, let's see here. If this is 54 degrees, then this angle right here would be 90 minus 54. And 90 minus 54 is 36 degrees. So that's 36 degrees. And if that's 36 degrees, okay, that's pretty good. That's pretty nice. That means this is 90 degrees right here. And that means this angle right here would be 180 minus 90 minus 36. So that makes this angle 54 degrees, which I also should have known through the fact that we have, alternate into, anyway, I don't want to get into too much geometry, but okay, that makes sense. That's 54 degrees. Okay, so using 36 degrees, now I can find this distance right here. How am I going to find that distance? Well, I know that sine of 36 degrees equals, I'm going to call this distance W. It equals W divided by 20. Remember, 20 is this distance right here. I do have it labeled. It's just kind of not labeled directly there, but it's to the side. So this distance right here is 20. Right here, this is 20. So again, I could find W by doing sine of 36 degrees equals W over hypotenuse 20. So 20 times sine of 36 degrees equals W. So I'm going to go to my calculator. 20 times sine of 36 degrees. W is 11.76. Okay, and I could also find this distance right here. I could find this distance right here using cosine. Cosine of 36 degrees equals the adjacent, let's call that M, divided by the hypotenuse 20. So therefore, 20 times cosine of 36 degrees equals M. So 20 times cosine of 36 degrees is 16.18. So 16.18 equals M. Now I'm getting there. I'm almost done. I'm almost there. I'm literally right there. Now the entire length of this bottom side is going to be M plus 40. Remember, I knew that this was 40 because that was the due west I went. So that means that the entire length of that bottom, so let me just draw this big triangle now, right? Maybe this will make a little bit more sense. So here's the big triangle. X is the hypotenuse. I found that this W over here was 11.76. This entire base is 40 plus M, which is 16.18. So 40 plus 16.18 is 56.18. And that's this right here. And now, how do I find X? Pythagorean's theorem. 11.76 squared plus 56.18 squared equals X squared. Now, I know I'm rounding in the middle of the problem. And if you want to be more exact, instead of plugging in 11.76, you could plug in 20 times sine of 36. I mean, just a little bit more hassle writing it, but you could do it. So 11.76 squared plus 56.18 squared equals 3,294.49 equals X squared. Take the square root to find X, and the square root of 3,294.49 is 57.40. So 57.40 nautical miles is the distance back to port. Pretty easy, pretty cool. Now, the other thing they wanted me to find was the bearings back to port. So right here is where I ended. I'm going to draw a compass right there. And my bearing would be how far I'm going to go from the south. So it'd be this angle right here, right? Be this angle right here. So there's my angle right there. So how do I find that angle? That is the angle that would be what? That'd be southeast, but it's the angle from the south. Well, again, I'm going to have to use an inverse. So why don't I go and use tangent? So tangent of theta equals opposite, 56.18, divided by adjacent, 11.76. I'm going to pull the old switcheroo. Tangent inverse of 56.18 divided by 11.76 equals that angle. So tangent inverse of 56.18 divided by 11.76 equals 78.18 degrees. So that angle is 78.18 degrees, and that is my bearing home. So it'd be south 78.18 degrees to the east. There you go. Now, I think I did a decent job explaining that problem. Maybe it could have been a little bit better. My picture drawing skills is certainly to be desired. It's not great. So I hope you do understand it, but it does start with understanding that if I go straight west for 20 miles an hour, 2 hours, 40, then I'm going to change my direction. So that's now my 20 nautical miles there. And then really the key to this was adding the triangle, adding the right triangle at the bottom here, on the bottom left. Adding that right triangle was really the key. And then I could look at the overall big triangle that I drew over here. So maybe watch it again to truly follow my lead on how I did that, but hopefully it wasn't too bad. All right, guys, so those are a lot of good word-ish type real-world problem-ish problems that really involve a lot of really good trigonometry. All right, good luck.